Welcome back, guys. We are on the next page, which I believe is page 13 in your shiny book, and we are continuing our lesson 2 about subtraction of positive and negative integers. So on in the previous video, in the previous page, we figured out that we have two equivalent expressions. We know that 5 minus 3 is the same as 5 plus negative 3. And then down here we have a little three-step process that helps us to rewrite this subtraction equation into an addition equation. So the first number always stays the same. We change the subtraction to addition, and then we change the sign of the second number. So 5 minus 3 is the same as 5 plus negative 3. So we're going to use this little three-step process to help us rewrite subtraction as addition, and then use that movement on the number line to model the addition just like we did in the previous lesson. So this means that every subtraction problem can be written as an addition problem. So here is another really quick example. Let's say you have 10 minus 7. That is a subtraction expression, and of course we know that the answer there is 3. So if we were to use this same three-step process, we would leave the first number the same. 10 doesn't change. We would change the subtraction to addition, and then we would change the sign of the second number. And although you can't see it, this little 7 here is positive. And so we're going to change the sign of that second number. Instead of being a positive 7, now it is a negative 7. So we've taken our subtraction equation and rewritten it using addition. And so 10 plus negative 7 has the same outcome as 10 minus 7. And that might seem obvious. It's going to come in handy later on when we start having different signs here, like when we start adding in some more negative numbers, and it gets a little more complicated. But this lesson is basically how to get from subtraction to addition, and then once you have the addition here, using that movement on the number line to get your answer. So if you know how to add positive and negative integers, you know how to also subtract them by using this process to rewrite the subtraction as addition. And here are some examples. So we have 4 minus 4 equals 0. And obviously we know that 4 minus 4 is 0. That's a very simple subtraction equation. But if we were going to rewrite this subtraction equation using these three steps, we would have 4. So we leave that first number the same. We change the subtraction sign to an addition sign, and then rewrite the second number. We switch the sign of the second number. So instead of, this is a little positive 4, we switch the sign of it, and now it's a negative 4. So 4 minus 4 is the same as 4 plus negative 4. And if we were to model that on a number line, so you start at 4, start at the first number, we add a negative number, which means we're going to go 1, 2, 3, 4 to the left, and we stop at 0. So we know that 4 minus 4 equals 0, and we also know that 4 plus negative 4 equals 0. And if you remember from last week, these two are called additive inverses, and so they add up to 0. And that's actually exactly what we have going on here. So this little subtraction equation that I wrote is right here, and it's the same equation, so it's modeled with the exact same number line. In our other example here, same idea. So 1 minus 3, if we were to rewrite that using addition, we're going to leave the first number the same, we're going to switch the subtraction to addition, and then we're going to change the sign of the second number. And by the way, that's what's exactly right there. And when you see this movement on the number line, so you start at that first number at 1, add a negative 3 to it, which means you're going to walk 3 units to the left and stop at negative 2. And the answer was negative 2 over there as well. So these two equations are the exact same thing. One of them is written using subtraction, one of them is written using addition, but they have the exact same answer. So in the reflect question, we're going to answer this question. Why can you write a subtraction problem as an addition problem? How do you write a subtraction problem as an addition problem? So the answer to the second piece is up here in this box, but why can you write a subtraction problem as an addition problem? The reason that you can write subtraction as addition is because subtraction and addition are opposite operations. So follow along with me. I want you to write what I write right down here. So subtraction and addition are opposites, so you can take a subtraction expression and you can rewrite it using addition because subtraction is the same as adding the opposite. And we're going to write an example of that next. So the second part of the question says, how do you write a subtraction problem as an addition problem? So we're going to use the example 5 minus 9. And we're going to rewrite that using addition and using this three-step process up here. So 5 minus 9 could be rewritten as addition by leaving the first number the same. So we're going to leave 5 the same. We will change the subtraction to addition. And then we'll change the sign of the second number. So instead of a 9, this is going to be a -9. And then we want to put some words to the second question. How do you write a subtraction problem as an addition problem? So I'm going to write some arrows here. This number stays the same. The first number always stays the same. We switch the subtraction to addition. So we'll put change to addition. I'm going to use a little plus sign in parentheses to represent addition. And then we're going to change the sign of the second number. So this 9, positive 9, became a -9. So we'll say change sign. And you might see this referred to, this whole process referred to as keep, change, change. Sometimes when I've taught this in the past, we use that little acronym to remind ourselves to keep the first number the same, change the subtraction to addition, and change the sign of the second number.